Very good afternoon to all of you. Today we are going to learn the linear equations or first order differential equations. Okay, when you have here first order because we have dy dx, mean the up to first derivative. Linear because coefficient of your dy dx is function of x or a constant value. Okay, mean this is a function of x, is also function of x. Right hand side is a function of x or can be a constant value. Power for dy dx is power 1, y power 1. So this is a first order because you have only up to dy dx. Linear because their power are 1 and their coefficient of dy dx, y in the right hand side are function of x or constant value. Okay, if we divide each term by ax, so you have bx over ax, let's denote as px, cx over ax, that denote as qx. So this is what we call first order linear equation in the form of dy dx plus pxy equal to qx. Let's go to directly the solution of the linear differential equations. We have a dy dx plus pxy equal to qx. So first step, you identify the px, you integrate p respect to x, then you get this is what we call the integrating factor, which is exponent integrate p dx. Oh, this is a long method, so we have the simplest methods. Okay, simplest way of solution of linear differential equation. Identifies a px, qx, gets a integrating factor. Get the integrating factor, which is exponent integral p dx, and then okay. Here, you multiply both k out. In the solution of the linear differential equation is actually first step you identify px, qx. Second step integrate p respect to x. So you get this is actually what we call the integrating factor I. This one. This is actually integrating factor I. So the solution of first order linear equation is actually we have I multiply y equal to integrate of I q, qx dx, and then plus c. For example, solve the equation, the linear equation dy dx plus 2xy equal to x. So your px is 2x, okay, the qx is x. So integrate p dx, integrate 2x dx, we have x squared plus c. This is long when I can definitely fix the using the shortcut way. So integrate p dx, you got x squared. So your integrating factor, it will be exponent x squared. Exponent x squared. So the y, okay, you have exponent x squared. And actually you have here exponent x squared. In the solution will be exponent x squared times the y, okay, equal to, you integrate, okay, exponent x squared x dx. The first step identifies your px. Qx is the x. The solution will be the integrating factor, which is the exponent integrate p dx multiply y equal to integrate the integrating factor multiply the qx dx. Okay, now we integrate the right hand side, integrate x exponent x squared dx. So this one. So integrate x exponent x squared, we have half exponent x squared plus c. Okay, and then what we want to solve is y. That's why you divide both hand side by exponent x squared. Okay, that's why you will get y equal to, in this one, it divide by this term, so y become half. Okay, exponent x squared divided by exponent x squared, it just left half. So this one plus c over exponent x squared or c exponent negative x squared. Okay, some of you may wonder how to integrate exponent x exponent x squared. Actually use a substitution technique. Replace the x squared by you replace your x squared here by u. So you have exponent u, and then x dx is actually, okay, u is x squared, so du dx you got 2x, so du is 2x dx. So replace the x dx by du over 2. So integrate exponent u du, you get exponent u. Replace back the u is x squared, that's why you got half exponent x squared plus c here. And how to integrate here is from the substitution techniques. Okay, add one more. Okay, solve the x dy dx minus 3y equal to x squared. Okay, we rewrite into the form of dy dx plus pxy equal to qx. First case, we divide the coefficient of x here, divide each term by x. So here become 1 dy dx minus 3 over xy equal to x. Then so px is negative 3 over x, qx is x. Then integrate p dx, integrate negative 3 over x dx, got negative 3 ln x. So the integrating factor, exponent, integrate p dx, you got exponent negative 3 ln x. So negative 3 you can rewrite as exponent ln x power negative 3. So e ln fx, you get back fx, which is x power negative 3. Hence the integrating factor you have here, exponent x power negative 3 multiplied by the y equal to, integrates your integrating factor exponent negative 3 times, because qx is x here. You take the x negative 3 multiply x, and then integrate respect to x, right? So it becomes integrate x power negative 2 dx. So that's why you have integrate x power negative 2. We got for integrations the power will be increased by 1, so it becomes x power negative 1 divide by negative 1, so become negative 1 over x plus c. So to get the y, you divide each term by exponent by x power negative 3. So multiplied by x power 3. So x power, so it becomes c x power 3. So x power 3 divided by x, we've got negative x power 2. We still have one more, the last one. solve dy dx minus y equal to sin x. This is linear equation because dy dx power 1, y power 1, right hand side, this is the function of x, coefficient of dy dx and coefficient of y are constant. So this is a linear differential equation. So identifies the px will be -1, qx is sin x. So integrate p respect to x, you have negative x. Integrate -1, you have negative x. So the integrating factor, exponent to the integral of p dx, you got exponent negative x. So the solution will be the integrating factor, exponent negative x multiply y equal to the integral of exponent negative x multiplies the qx, which is sin x. To get qx, make sure coefficient of dy dx here is 1. So integrate exponent negative x sin x dx. You get here. This is we solve it using tabular method. Later I will show you. Okay. So to get y, you multiply both terms. To eliminate exponent negative x, you multiply both terms by exponent x. So this one become 1. So it becomes c exponent x. Okay. The notes how you integrate exponent negative x sin x dx. Let's show you. This is using tabular methods. Okay, I take the du as a sin x, dv as a exponent negative x. How you integrate? I take, okay, this is du, dv is exponent negative x dx. Tabular is a systematical way of integral by parts. So for du, you differentiate, okay, dv you integrate. If you don't have the polynomial, then for tabular method, is normally to integrate the product form of exponential, trigonometrics, and the polynomial. If you don't have the polynomial, if you got polynomial, then polynomial will choose it as a u. But if you don't have polynomial, then we normally just do 3 rows. Just only need to do 3 rows. If you got polynomial, choose a polynomial as u, and then you just differentiate until the du here you get 0. So differentiate sin, positive cos, sin x get positive cos x, differentiate cos, negative sin x, integrate exponent negative x, we have negative exponent negative x, integrate one more time, positive exponent negative x. So the result, okay, you have sign start from positive, negative, positive, alternate. The result, the slanting is a result of integral. The horizontal is actually carry the integral symbol. That's what you do, the integral by part, integral u dv. The result you have uv, because differentiate. So this is not du. This is actually u. So u dv, and then minus v du, right? Minus v du. So this is u dv, because this is mean if you do tabular method several, if you not use tabular method, use integral by part, you will need to do 2 times in this case. So this is the first time result, positive sin x multiply negative exponent negative x. Then the second row, negative cos x times exponent negative x. Okay, this one carry the symbol of actually your integral by part, integral u dv. Answer is uv, minus v du is here. Okay, that's why the result you have here. Negative exponent negative x multiplied by sin x. Okay, second term, negative cos x multiply exponent negative x. Negative cos x multiply exponent negative x. Okay, the horizontal row is actually positive negative. So minus u dv. minus integral of u dv. So minus sin x exponent negative x. Okay, means if the u is not polynomial, we just need to do 3 times to get back the same term in the first row. Not consider the coefficient, sin x, exponent negative x, so that we can combine the integral. Yeah. You want to do integral of exponent negative x sin x dx. If you couldn't have the product of polynomial with either exponential or trigonometric function, you just need to do three rows, where the last row carry the integral u dv. So mean left side, this is a right side. So the first two slanting row is a result of your integral, and this is carried, okay, from the horizontal row minus sin x exponent negative x, the integration of minus exponent negative x sin x dx. So this one, you collect this term. Collect this term here to the left hand side. So total you have 2 times. Total you got 2 times. We collect this term to here. Total you have 2 times integral of exponent negative x sin x dx. This result. 2 times of this one is equal to negative exponent negative x. Okay, this term factor out. So you got sin x okay, minus, so it factor out negative, so this is a cos x. This. So you want 1 time only, that's why the right hand side divide by 2. Okay, that's how we get this one. So so we conclude back, okay, what is a linear equation? Okay, we have the form of 1 dy dx plus pxy equal to qx. Okay, we use a shortcut way how to solve it. Identify your px, qx. In first step, identify your px, qx. Second step, integrate p dx. Third step, get this, what we call integrating factor, exponent integral of p dx. Okay, lastly, the solution is actually the integrating factor times y equal to integral of the integrating factor qx dx plus c. This is actually they go through the by part, but it's straight away using using this formula. Okay, with this, thank you for your attention.